All right, so we're moving into a new section, which is really kind of an old section. We're going to be talking about 11.1 dilation. We've talked about dilation a little bit before. So here's just some example problems to kind of bring back some things to your memory. So for example, question 1 involves a dilation, and you all know dilation is when something stays the same shape, but it's going to be getting larger or smaller. So it could get smaller. Like I said, we've done this a little bit before. So question 1 talks about taking this image and kind of making it, pre-image and turning it into the image. So one of the things that we could do here would be to translate this. Remember, translate just means to shift. And then we could dilate it to make it larger. And make a note that this is going to make it larger. 2 is different. So in 2, notice that we've got this shape and we're kind of trying to move it to that one. So in 2, and I don't think this is counted correctly, but just general idea, this is going to be an idea of something that could be reflected. So if it was reflected, notice that it would, I'm giving a really rough sketch here, it would like turn around. And then it could be translated down to where it needed to be. All right, so in general, I just want to say that these are examples of something called, these are going to be congruent triangles, while these other 2 are going to be what we call similar triangles. So let's talk about what makes something similar versus congruent. So congruent, these are where you really need to start your notes. Congruent is something that is all the same shape and size. So specifically, it's all the angles being congruent that make it the same shape. The sides being congruent is what make it the same size as well, right? Think about equilateral triangles all have 60-degrey angles. So all equilateral triangles are similar. I can draw you a little picture here. Wow, let's pretend that those are the same. Okay, so like both of those have 60-degree angles, but right, this one may be like 2, 2, and 2, and this one's 5, 5, and 5. So this is an example of something that's similar but not congruent. So you want to note that congruence comes from when you have translations, rotations, or reflections specifically. All right, and congruent is marked with that same symbol that you're used to. Now, similarity is kind of a new ball game. Similarity comes from dilations, and similarity happens when you have all the angles that are the same, but the sides are proportional. And we'll work on these proportions a little bit when we get into class. All right, so have those notes about similar and congruent. You may want to draw this picture of similar triangles kind of down here with a similar. That's up to you. Let's look at a few examples of actually how to work with dilation, because we've done translations, reflections, and rotations already. All right, so let's start by talking about how to describe dilations. And the first thing that you want to know is that dilations are described using a scale factor. And specifically, if the image is getting larger, then our scale factor is going to be greater than 1. And if the image is getting smaller, then our scale factor is going to be less than 1. And additionally, you want to note that scale factors should always be positive. Even if it's getting smaller, it's just going to be a fraction. It's not actually going to be a negative number. So you should never use negative numbers with dilations. All right, so let's look at example 1 and then example 2. All right, so example 1, sorry, I'm struggling to zoom in on that. Example 1, the easiest thing to do is probably pick a side, corresponding sides that are pretty easy to count. So for example, if I look like VW is at an angle, that's going to be tricky to count. WX is angled and so is VY, but XY is a straight segment, so that's going to be easier for me to count. All right, so I'm going to count, I've got, let's see, this one looks like it's 2.5, so I'm going to call that 2.5, and the other one is going to be 5. Now, you need to remember your rules about which one's the pre-image and which one's the image. So the pre-image is the one without the apostrophes. The little apostrophes indicate that this one is the image. So it looks to me like this right here is going to be getting smaller. So the first thing we want to do is set up our fraction, and we have 2 options. We can either do it as 2.5 over 5 or 5 over 2.5. Now, if I were to use my calculator to reduce that, that means that my options for scale factor are either 1/2 or 2. So think about, if it's getting smaller, which number should we pick? And hopefully you see if it's getting smaller, we should pick this 1/2 number. All right, let's look at question 2. Similar concept there. All right, question 2, again, we're going to pick a segment that's easy to count, corresponding segments. So I have this SR, that's 2. And then I have S prime to R prime, which appears to be 5 total, maybe? Yes, that is 5 when you count that out. Okay, so we're going to compare those. Now notice this time, I'm going from pre-image, which is the one without the apostrophes, to the larger one. So this is getting bigger. So again, I'm going to start my scale factor. It's either 2/5 or 5/2. And I want it to be getting larger. So which one of those numbers is larger than 1? Well, the 5/2 is bigger than 1. So this would be the scale factor for this problem. All right, so I'm only going to show you part of this so that you don't have to worry too much about getting the graph. We'll do some of those together in class tomorrow. But we want to talk about how to actually perform dilation. So the first thing we do is we're actually going to use coordinates and multiplication. Okay, so the example you're going to write down here is example 3. They want us to find the dilation of 1.5 of this figure right here. Find the new coordinates. So let me go ahead and zoom in so you can see the problem. What I said was dilation happens when we multiply. So we're going to take that 1.5 number and multiply it by each of the coordinates. So for instance, I'm going to do, let me write out what I'm doing. I'm going to multiply both of these coordinates by 1.5 times 1.5. That means t prime, the new t value, is going to be -3 and 1.5. If I did the same thing on s, multiply both of those by 1.5, I'm going to get that s prime is -3, and I think that should be 4.5. All right, so notice all I'm doing is multiplying the x and each y part, everything in there, by 1.5. You should be able to continue that, so go ahead and do that for the sake of your notes and figure out what r prime and what q prime should be, and we'll check those for a check on the board tomorrow. All right, and the last note that I just want to make to you, like I said, we're not going to do these graphs, but when you're graphing, so think about this picture, if they give you a picture and ask you to dilate, then you have to name the coordinates and then multiply. So those are the notes that you should have written down. When dilating from a graph, those are the 3 steps you're going to follow, and that's what we're going to work on together in class tomorrow.